1950s was a time when the term AI was first coined. Artificial intelligence as a term was first coined in the 1950s. And the whole idea was this was a Dartmouth conference where this term was coined. And a lot of researchers, they came together. And the whole idea was how do we make machines think and act the way humans do? Because 1950s was a very early era. We didn't have any computing devices, mobile devices. There was none of those things that were available around that time. And there was a huge amount of interest in the community where we wanted to we wanted to make machines think and act the way humans do. And that was the origin and that was the inspiration behind the term artificial intelligence. And we are talking about very basic rule-based programs around that time. Machine learning was a concept that evolved a lot later. And if you look at the term AI very broadly, if you look at the term AI very, very broadly, there is one kind of AI which is seen all around us generally today, which is called rule-based intelligence. That is, how do you explicitly make a machine do certain things through hard-coded rules? And that is what I want to start my discussion very, very briefly in the session now. So take an example of a air conditioner. Let's say you have an air conditioner that is running in your room right now, and the temperature is set to 27 degrees Celsius. What does it mean? It means that somehow that air conditioner automatically understands how to adjust its temperature. The air conditioner automatically understands how to monitor the temperature of its surroundings and automatically maintain the temperature at 26 degrees Celsius or 27 degrees Celsius. So there is some kind of a sensor that is present within the air conditioner, which is constantly monitoring at what temperature the room is at. So if the room temperature goes above 27 degrees Celsius, the compressor will stop temporarily. And if the room temperature goes above, it will start. So it is constantly monitoring the temperature of the room. So if your room temperature goes above 27, the compressor will start and it will rapidly start cooling the room. And if your room temperature goes below 27, the compressor will stop. And you would have seen these kinds of auto climate control modes in cars and homes and other kinds of things. If you think about it, this is also some kind of intelligence, isn't it? If you think a little deeply about what exactly is happening here, there is also some kind of intelligence that is working behind the scenes, and that is what we refer to as rule-based intelligence or intelligence that is driven by a static hard-coded rules. That's the way how we look at the term rule-based intelligence. Now, what I wanted to do is I wanted to quickly share across a small snippet with all of you where you can get a deeper understanding of exactly what rule-based AI refers to. Everybody is able to see this, and you can see that rule-based AI is that kind of AI where you tell the machine what to do, how to do it, and the machine does it for you. You provide the set of rules, you provide the set of static rules. You explicitly tell the machine what to do and how to do it. The rules are hard-coded, the rules are static. And that is what we refer to as rule-based intelligence. There are many examples. You can think of a modern day automobile and imagine you are looking at a seatbelt alarm, right? So how does a seatbelt alarm basically work? If somebody wears a seatbelt, if the sensor detects that somebody is wearing the seatbelt, everything is fine. If the sensor detects somebody is not wearing a seatbelt, there's a small beep sound that will continue happening. All of you have seen that. Or let's just say an automatic speed control alarm. So you might have seen there are cases where if the car goes above a particular speed, especially in commercial cars, it happens where the speed limits are up to 100 or 80 kilometers an hour. And if you go above a certain speed limit, the a kind of sensor will be triggered and a kind of beep sound will come up. And there are countless other examples we can continue talking about. Automatic headlamps, which have light sensors, right? Or even in your offices, you go to your offices and there are motion sensors. And whenever a motion is detected, the lights will come up, else the lights will automatically come down. Now, if you think about that kind of technology, it's intelligence, isn't it? It is artificial intelligence. It is some kind of intelligence that the machine has to sense your presence. If something is moving, if I am present, the lights are coming on, else the lights are coming off. There is some kind of intelligence, and that is what we talk about in terms of rule-based AI. And this is what traditional programming helped us do. So when we write traditional software programs, this is exactly what we are doing. We are building systems. We are explicitly writing code. We are writing software using different programming languages. We're explicitly telling the machine what to do and how to do it, and the machine is doing it for us. And that's the way how we look at traditional rule-based intelligence. And there continues to be many applications of this as we speak today. Even if you go to a factory, there are so many machines, automatic machines that are in the assembly line, which are constantly manufacturing products and assembling different types of products. And if you think about it, that is also a classic example of rule-based intelligence. It is not that the machine is able to figure out how to do certain things, but we have pre-programmed instructions. If you look at all the different factory robots that are out there, you look at a car assembly plant, okay, any of the major car assembly plants, if you see, there are so many machines that are operating there, and they are doing different things, right? So something, there's some machine that is assembling the tire, assembling the chassis, assembling the car windows. There's different machines that are meant for different tasks. And if you think about it, there is some kind of instruction that has already been provided in advance. Somebody has written the code, somebody has explicitly told the machine and trained the machine what to do and how to do it, and the machine is simply blindly following your instructions. And that is, again, what we refer to as rule based intelligence. So that's the first thing I wanted to start out with so that everybody realizes. And any kind of sensor based applications that you see, anything where there is a sensor and based on some kind of a sensor trigger, something happens, it's intelligence, but it's a very basic form of intelligence. And this is what we are talking about in the 1950s when we didn't even have the computing devices we have today, right? The world's first computer system was called ENIAC, and that came around that time. So we didn't even have computers around that time, and it was quite a revolutionary thought. Okay, so what changed? What changed from there? If we can write rules to solve so many problems, then what changed? So what changed was people realized that okay, we can solve a lot of complex problems, even to the point of even when personal computers came, we even have softwares that we write today. And whenever you write code in any language for that matter, let's say you write a Python script or a JavaScript or a shell script, or a Perl script. What are you actually doing? Whenever you write a program, what is software? What do we even mean by the term software? Software is basically a set of instructions that you're explicitly giving to the computer, right? Even your operating system is a kind of rule-based AI. Every aspect of the computer, even if you talk about the mobile phone operating systems, every aspect of the way your mobile phone is working is controlled by rules. The rules have been hard coded. Every aspect of the laptop is controlled by rules. And that operating system, the Windows operating system or the Mac operating system, is a very complex set of instructions. Hundreds and thousands to tens of thousands of lines of code, which explicitly control every single aspect of how your system is working. Yes, there are a lot of other machine learning aspects that are starting to come up in operating systems now, but a big part of how your laptop is functioning today is driven by pre-programmed rules that goes to memory management and resource management, everything is pre-programmed generally. Okay, so sometimes you will see that whenever you open up a very resource intensive program, sometimes your fan speed will increase. Who is controlling that? Isn't it magical? Sometimes when you open up a game or a very intensive application, you will see excuse me, you will see that your fan speed revs up, the fan increases, or the other applications, sometimes it goes to not responding. And who is controlling that? These are all given by rules. So all this was great. Okay, all this was great, everything was fine. But gradually we realized that rules cannot help us solve everything. This is something we gradually realized, that rules cannot help us solve everything. There are a lot of complex problems that rules cannot solve. And that was a realization that we had generally. There are a lot of complex problems that we cannot solve with rules, especially in the domain of images, audio, video, and text, unstructured data. Let me give you an example. Let's talk about Google Photos for a minute. Okay, so you go to Google Photos, and we can use Google Photos to identify and uh, classify so many different types of everyday objects, right? So let's talk about a simple example of elephants, right? So we can look at a a very, very simple example of an elephant. So what is really happening? What is really happening behind the scenes when you're using Google Photos to identify elephants, right? So let me see if I can bring up a small demo for you. So let me just quickly bring up a small demo for you. I'll open up my Google Photos and maybe show you some examples of elephants, and you can take it up from there. So if you see the screen here, just brought up a couple of very small demos for you here. You can see very interesting. And Google has also very recently modified their photo search actually, so they bring it up in two places now. So one is most relevant. You can actually type text. So they're slowly starting to use Gemini in a big way in their applications today. And so traditionally, and that's a different conversation. But traditionally, what used to happen is you have to search explicitly by those terms. You have to say elephant, sun, moon, like that. But a big part of the search that you can do today is just using natural language. Okay, so it's like you can just go and uh, enter something in natural language. You can just say, okay, I want to see pictures of elephants when I was there in this last year. You can just say something in English, and Google will still return images for you, which is a very, very interesting thing. Anyways, so what is going on here? Let's talk about it for a minute. So think about it. Can we write a piece of code? Can we write a piece of code to identify elephants? Think about it. So when we looked at rule-based intelligence, as part of rule-based AI, we are supposed to hard code the instructions. We are supposed to explicitly tell the machine everything that we want to do. And that is how traditional softwares are also developed, right? If you look at traditional software development and a large part of the software development that happens today, if you want to create a website or you want to design something, an application, this is exactly what you will do, right? You will get your requirements, you create your design documents, you write your code as per the design documents, because every single aspect of the system is known to you. You know every aspect of your system. If this happens, this will happen. If this is the input, this is the output. Every single aspect of your system will be controlled, right? So the requirements are known to you, and you're simply writing code to make the system do what you want it to do. That's the way how we look at rule-based intelligence. The problem with pictures is there is no one way to identify elephants, right? Think about it. What you're seeing on the screen here, there is no single way to identify elephants. There are so many different ways elephants can look like. Elephants may have a tusk. Elephants may not have a tusk. Okay, and you can see very interesting. This elephant has a broken trunk, or at least it seems like that. I don't think this trunk looks like it's normal, right? This is maybe you can see this is a broken tusk. So, so there can be so many different ways elephants can look like. The normal elephant is like what? We have four legs, one trunk, two tusks, two big ears, two eyes, maybe a dark color. That's how we can explicitly identify an elephant. But if you're trying to write hard-coded rules, if you're trying to write rules, and if you're explicitly trying to hard-code rules, how do you then how will you define elephants then? It will be very hard to do that because some of the rules could be like, okay, if I see two tusks, then it's an elephant, isn't it? Tusk is such a defining factor of an elephant. So it's like so think of rule-based AI as an if-else statement. You're writing an if-else statement. If this, then this will happen. If I detect motion, then the lights will be on. Okay. If the light is less than the white, then the headlight will come on. Rule-based intelligence, if-else statement. So similarly, it's like saying if I see two tusks, then it's an elephant. And there are ways to program it. We can, pictures are pixels, and we can program something based on pixels. But look at the baby elephant here. This is also an elephant, right? So the same rules that work here, those rules will not work here. That's the problem, right? That's what I told you. There's so many different ways elephants can look like that I cannot just have a fixed rule-based criterion. I cannot just say that, okay, if I see two white tusk or teeth, then it's an elephant, else it's not. Because there can be elephants which don't have a tusk, or they can be elephants that have only one tusk. Maybe here it is half broken. You might have an elephant where the entire tusk is broken, and maybe it doesn't even have a tusk, maybe on the left hand side or the right hand side. So there are so many varieties. And if you see here, the legs are not visible. I can only see two legs very prominently, but the other legs are not visible. So does it mean that this is not an elephant? If I see two legs, what do I call it? Do I call it a human? No, of course not. So you can see how difficult it is to actually explicitly write rules for images. Now, elephants we can still talk about. We can debate and discuss about elephants, but it gets incredibly difficult. The moment we talk about other kinds of objects. And let me take an example. Let me take an example with all of you with respect to mountains. Elephants are still maybe something we can debate and discuss. But what about mountains? How do you go and write and identify mountains? Right? Look at this, all of you. I've searched for mountains on Google Photos, and there are so many infinite number of different ways that mountains can look like. Okay, so it's a very new feature actually. That's what Google is saying. It's new. This is very recently launched actually. Anyways, so sorry. Let me just remove it. I think it doesn't go. Okay, so we mountains can be brown, mountains can be white, mountains can be green. There's so many different ways mountains can look like. Okay, so there's no one way I can write a piece of code to identify mountains. And this is what I was talking about when I'm discussing rule-based AI. So there's no way that you can write a specified explicit set of rules saying that hey, this is mountains, this is not mountains. Impossible. Mountains can be green, mountains can be brown, mountains can be white, mountains can be, they can have a triangular kind of shape, they can have this kind of a shape, or they can just be plain flat. Okay, mountains can also be plain flat, and just no way, there's just no way that you can explicitly write code to identify mountains. Okay, so what I'm getting at again is there are a lot of applications where you will see there are a lot of applications, real applications where you will see that it is very hard to program rules. And if you take this conversation to audio data, speech data, I was discussing the transcription use case with all of you. If you take this example to speech kind of data or audio kind of data, it is very difficult to do that there. There also it is extremely hard to do. Okay, imagine I'm saying something and the meeting transcriptor is trying to convert my entire speech into text. Speech to text is impossible to do using rules. You cannot define hard-coded rules. You cannot explicitly tell the machine that, if the audio is like this, then the text is like this. It's impossible. Even simple things like the way Google recognizes our speech, like even something like when you say, okay, Google. So Google is trying to recognize, actually my Google also fired up now as I said it, but think about it. There's so many infinite number of ways we can say, okay, Google, right? Think about it. So when we say, okay, Google, it is not, it is not just one way we can say, okay, Google. There are infinite number of ways I can use that term, right? So how do I pre-program rules? It is impossible. It is very difficult, and it is literally impossible to pre-program audio signatures and say, okay, if the audio is like this, then it means this. And if the audio is like this, it means this. And it's just impossible because there are so many varieties and there's so many infinite number of ways things can happen. And that is where the challenge of rule-based AI comes in unstructured data. That oftentimes the rules are hard and the rules are unknown. We don't even know what the rules are. Sometimes the rules are hard, like for elephants, they are hard. And sometimes we don't even know what the rules are, like mountains. What rules do I write? How do I even know what is a mountain? You can take a picture in the middle of a green rainforest, which is up on a mountain, and Google will still know it's a mountain. There is nothing that tells you it's a mountain, but the model will still identify it's a mountain. So these are things that are impossible to hard code generally. So how do we do that? Now let's come to the conversation on machine learning based AI, right? So this is where people realize that we cannot design AI systems just using rules. We need to design AI systems. We still want to make machines intelligent, but now we want to make machines intelligent using something else called machine learning, where we want to make the machine learn the rules. We do not want to explicitly hard code the rules, but instead we want the machine to figure out the rules. We want the machine to figure out what the rules are. And that's the way we look at machine learning.